This is the next planet, Mars, the red planet. Mars is the god of war. So I guess the red represents blood. And when you see Mars from Earth, it does appear red. And you can even spot Mars in the night sky if you go out and find all the large magnitude stars and find the one that's reddest. And chances are you're looking at Mars. So you can even see the red color from Earth. And it's red because there's lots of iron, ferric iron, in the soil on the surface. Because Mars has an atmosphere and has lots of red dust at the surface, very often you get dust storms. This is a series of photographs that shows a dust storm that's forming. There's a cold front. It's coming down from the poles. It's like a big tongue of cold air. And as that cold air pushes in front of it, you can see the dust kicked up in front of it there. Here's another front of a dust storm moving across the surface of Mars. This is what Mars normally looks like. This is during a global, for Mars anyway, a Marsian, I guess, Martian, a complete Martian dust storm. In other words, the whole planet's surface is covered with dust that's kicked up in the atmosphere. You can see in this photograph the atmosphere of Mars, like the Earth's atmosphere. The surface is very rocky, and you can see the large impact craters that pock the surface. There's that cold front again. You see the dust storm pushed out in front. There's the ice cap. Just like in the fall and winter when we get cold fronts coming down, these big tongues of cold air, this you see the same thing on Mars. This is the South Pole. Ice caps there, North Pole. This is a glacier, what's left over from a glacier. So even though it's not liquid water, the ice, if it's thick enough, can actually flow, like a river of ice. And this is the moraine that's been produced by this tongue of ice. Sometimes you'll even see pockets of ice that have collected impact craters. But anyway, that's the South Pole of Mars. When we first began to look at Mars with the telescopes, astronomers thought that they were seeing canal systems. They even drew maps of the different canals. And if there are canals on Mars, there's what on Mars? Canals, then there's people, right? Because canals are made by people. And so when they began to see these linear features on Mars and they thought that they were canals, it led to this belief that there were other people living on Mars. That's the reason we call them Martians, right? Martians, because they're from Mars. And it created this strange scenario that the Earth is being visited by alien creatures from Mars. And you get into the 40s and 50s and you have all the sci-fi stuff. And it comes from these telescopic observations. The problem is when you look at Mars today, it's hard to tell exactly what they were looking at. It may have been some kind of distortions in the lenses of the telescopes themselves that were causing it. But we still are scratching our heads trying to figure out what it was they're seeing. We've taken photographs of the surface, and you can see things that look like canals, but there's no way that's what they're seeing. They couldn't see that kind of detail from Earth, but it looks somewhat similar to what they were drawing. So that's kind of creepy. One thing that does stand out on the surface of Mars is the Grand Canyon of Mars, which is about the size of the United States. It would be like a canyon that went from Maine to San Diego, all the way across the United States. Grand Canyon on Mars, gigantic. You can see the landslides here. That's landslides the size of Maryland. That's just sloughing off into the canyon itself. So the Grand Canyon on Earth would be like the size of one of these little tiny splay canyons right here.
Nice.
It's inside structures of the canyons. The probes have allowed us to photograph the surface features of Mars, and we can see a lot more detail. You recognize these objects?
Tracks.
Nope. They're sand dunes. Sand dunes, which would make sense, right? Dust storms, you're going to get sand dunes. Those are Barkhan dunes. Here's some more sand dunes. Seif dunes. So we're seeing the same types of features that we see on Earth. erosional type features, because the processes are working the same way, the terracing that occurs due to differential erosion of the rock layers. This is permafrost. Like I said, there's frozen water inside the soil, and so it creates these boiling patterns that you see. And then, of course, there are impacts. Here's a large meteor impact on the surface of Mars. You can see the frozen water has been liquefied for just a second as the heat from the impact has melted it. So you had liquid water for a second or two. Other large impacts on the surface with dunes in the interior. We've sent two probes that landed on the surface of Mars, and these are some of the photographs that they've taken. So you can get an idea of whether you want to go on vacation there. It's kind of boring to me, though. Not a whole lot to do. There's Texas on Mars. Now, they drew the state of Texas to show you how large that volcano is. So you've got a volcano on Mars that's like a quarter the size of Texas? And we know Texas is big, so that must be a big volcano. Olympus Mons is what they call it. It's a shield volcano. You see the crater at the top. That's not an impact crater. That's a volcanic crater. It's a shield volcano, so it'd be very low angle. It'd be much harder to see than what we normally think of with a composite volcano. The probes could see it. You could see it with the probe, but not from Earth. I mean, it's too small. Even though it's a very big feature for volcanoes on Earth, it would be small compared to the size of the planet to be able to see it. Those are the caldera, the craters there at the top. Anyway, you can see the dust storms have created tremendous erosion around the perimeter of it. Olympus Mons. There are smaller parasitic craters, and you can even see lava flows that's built up. It's not molten now, it's hardened. You see at one time it was a lake of lava that flowed out here into this lava flow. So indications of active volcanism. We know it's fairly recent because there's no impact craters. See that? If it had been an older flow in a dormant volcano, there would be impact craters on it. Anyway, this is Mars from one of the probes. You can see Olympus Mons and other volcanoes surface. When we sent the last probes around Mars, they brought back these images of this face, and it gained quite a bit of attention, right? The face on Mars that supposedly was clear indication that there really was a civilization that existed there one time, and they carved a face out of this mountain range. And that is a mountain range. That's about 8 miles. So they have a sculpture like would make Mount Rushmore look like child's play. It's a gigantic face carved in a mountain range on Mars. This is a photograph taken the surface of Mars. You can see the rocks, how they've been shaped by the wind. As the wind's blowing sand along the surface, when it hits the rock, it cuts these facets, these faces. So when the wind's blowing from this direction, it cuts this face. From this direction, it cuts that face. And so the small fragments of sand hitting the rock is like sandblasted it. They're called ventrifacts. And you can see all of these are ventrifacts. They're shaped by the wind. Here's a close-up of one. This looks like it's been man-made, but it's not. The wind did this. You see it on Earth. This is a photograph of one on Mars, so we know the same thing happens on Mars. And so what you're looking at when you look at this face on Mars, you're looking at a ventrifact, just a very large ventrifact. It's a ventrifact the size of a mountain. But the processes are still the same because you have sandstorms on Mars that encompass the whole planet. So therefore you can create these types of features. So in other words, this is probably a naturally made formation. It just happens to look like a face based upon the direction of the sun. They went back and photographed that same thing from a different perspective because they thought maybe it is a face, and this is what it looks like. So see what I'm saying? You can see the brow ridge here, the nose, but when you get it with different light, it's pretty obvious it's not a face. It was just a coincidence in the earlier one. This is a three-dimensional projection of it based upon what they know. So you're not going to see a face. It's just an accident. So when you hear about the face on Mars, then you know it's just something that was in the newspapers at one time. If they had shown the whole picture too, you would see that there are other ventrifacts, same size. See it? See the face here? There's the face. This is the whole photograph. There's the face, but look, see, there are other ventrifacts. See, the sides of the mountain have been shaped by the winds. Smiley face on Mars. I don't know why they don't make much of that. See? Smiley face. But anyway, these are large impact craters. This is the heart on Mars. The golf ball on Mars. God's golf ball. The ultimate sand trap. Oh darn, I hit Mars again. Yeah, I don't know if that's left over from an asteroid or something. It's really crazy looking. Could be, yeah. I think you're right, all in one. These are photographs taken from the first lander on Mars. The earliest probe on Mars took samples, had a little arm that reached out and would rake in the soil, and they could do experiments on it. The first experiment began to show different reactions, and it suggested there were organic material in the soil. So they published the fact that they had discovered life on Mars, but it wasn't really life, it was just an indication there may have been organic material. But later they recognized that that was a false positive. There really wasn't any organic material on Mars. Carl Sagan was the one pushing this, and he, after that, he said that even though we didn't find organic material on Mars, he said that we have to be careful because we think of life in terms of carbon-based life. Our bodies are made up of carbons. But he said it may be that life on Mars is a silica-based life form. And everybody goes, oh yeah, silica-based life form. They didn't realize what he was saying. When he talks about a silica-based life form, you know what he's talking about? The rocks. Rocks are made up of silica. So you go to Mars and what do you find? Rocks. And so he's saying maybe the rocks are alive. They're just perfectly still while we're watching them. Whenever we go away, they start partying down on the surface. But it caught on. There was a movie called Andromeda Strain. And if you've ever watched the movie Andromeda Strain, it's a bacteria that comes to Earth from outer space and infects the Earth. And guess what kind of life form the Andromeda Strain is? It's silica-based. It's life, but it's made up of silicates, like a rock, not carbon. Probably not, though, but I guess if that's all you have on the surface of silicates, then silica-based life form sounds pretty reasonable. The second lander was actually a little go-kart. You can see the shadow here as it's moving across the surface. So it can move from place to place and get these types of photographs. So if you went to Mars, this is what you'd see. This is a dust devil that passed in front of the lander. So it's a smaller version of the dust storm. Yeah.
Were those solar panels that it laid out?
Yeah, that's right. That's what it uses for power source. It processes sunlight to be able to create the energy it needs to power the batteries to move it. But anyway, sand dunes, ripples, rock formations. You see the sand dunes here that are crossing over the bedrock. This is an impact crater from the ground. Sorry, we can't take a field trip there. It'd be too expensive. See the cross beds from sand dunes that have turned into rock like we see on Earth? Sunrise on Mars. Earth. In other words, the camera, when they're on Mars, they turn the camera to the night sky and got a photograph of Earth. So yeah, that's quite a ways away. That would make you homesick, wouldn't it? Look up, see this little tiny dot and recognize that's Earth. That's your home.